Hey everyone, today I'm going to show you how to deploy a starknet account using starknet.go, and more importantly, I want to show you how the starknet.go docs have literally everything that you need to build on starknet using Golang. Things like deploying accounts, invoking contracts, and reading events. It's all in here with copy-paste examples. So let's walk through it together. So this is the starknet.go documentation site. On the left, you have got a sidebar with everything organized very nicely. We have got an introduction section for getting started, and then detailed docs for each of the modules like account, RPC, devnet, contracts, utils. Today, we are deploying a contract account. So let's start with getting started and then jump to the deploy account example. So in getting started, you can see there are some prerequisites, and this is how you set up a project. So basically what we have to do is that copy this command, spin up a terminal. Let me clear this, and then let us just paste this. What this is doing is that it is creating a folder named my starknet app. We are going inside that folder and then initializing a Go project. After this has been done, we have to copy this command, which is basically adding the dependencies to our project, which is starknet go and go.env. Okay. And the next part would be for us to open it in VS Code. Now here I have to create a main.go file and also create a .env file where our environment variables would be stored. Now, basically, you can see that the environment variable which we need is starknet RPC URL. So let me copy this, paste it here. And we have to get a RPC URL. I'll be taking that from Alchemy. Let me paste that. Then go inside the main.go file and copy paste as it is from the examples section. In the deploy account, we'll copy this code snippet and paste it inside the file. Now, as you can see, we might be facing some errors, which is from the compiler. Now, what we have to do is that run go mod tidy command so that it will install all the related dependencies. And then we would not see all these errors inside our code file. And as you can see, those have been resolved. Let me close this terminal. And now what I would do is that explain you through each part of this code and walk you through the whole process of deploying a account on starknet. So as you can see, these are some standard Go imports at the top. Then there are some imports like felt which is coming from Juno here, as you can see. Then there is account which is coming from starknet go and RPC also, which is coming from starknet go. And there is a utils packet which is coming from starknet go module as well. And we also need the .env module for us to import the environment variables from the .env file. Then we can see that there is a pre-deployed class hash, which is this, and it is present on Sepolia. Now this is important as on starknet, all the accounts are smart contracts, and this hash points to the OpenZeppelin's account contract that is already declared on Sepolia. So we are not deploying a new code. We are creating an instance of this existing contract class hash for our own account. If you look closely, this is a pretty standard setup where we are loading the environment variables, grabbing the RPC URL and creating a context, and then initializing the RPC client. The client is our connection to the starknet network. These are some freshly generated cryptographic keys, the private keys for signing transactions and the public key that identifies our account. And basically those are being created using the random keys, get random keys function from the account package. And we are also printing them here. Now we create an account instance. We pass in the client, which uses the public key as a temporary address for now, and link it to our key store and specify that we are using Cairo v2 since we are using modern Cairo contracts. This account object will handle signing and sending our deployed transaction. Now, in the next part, you can see that we are converting our class hash string to a felt. That's the format which starknet uses internally. Then we have the build and estimate deploy account transaction. Now, what is basically happening is that it is the key function for our explanation. And let me explain the parameters. The pub is basically the salt, which randomizes our contract address. Class hash, which is the contract class that we are instantiating. Then we have the constructor call data. The OpenZeppelin account takes the public key as its only argument. And then we are using nil because we are not using any special transaction options. Now this function does two things. It builds and deploys transaction and estimates the fee as well. The pre-computed address is super important on starknet. We can calculate our account address deterministically before it even exists on chain. Then we print the pre-computed address and save our credentials to the environment file, .env file. And this is crucial. You don't want to lose your private keys. And this is a helper function, save credentials to environment at the bottom of the file that handles this. You can go through it. It's pretty simple. Now for this section, starknet uses a resource-based fee model, which is res bounds map to overall fee, which calculates the total fee from the resource bounds that were estimated earlier. Then FRI to Stark converts from FRI, which is the smallest unit, to Stark, which is easier to read. The program then pauses and waits for us to fund the pre-computed address. This is the key insight about starknet account deployment. You fund an address that doesn't exist yet and then deploy the account contract to that exact same address. Once we have funded, we call send transaction with our deploy transaction. The response gives us the transaction hash and confirms the contract address, which should match our pre-computed address. Then we wait for the confirmation using this helper function. As you can see, this was the save credentials to environment helper function which I created. And then there is a wait for transaction helper function. So basically this polls the network every 5 seconds, checking if our transaction is accepted on L2 or L1. And once it is confirmed, we get the receipt with the block number and familiarity status. Simply polling pattern, nothing fancy. So, all right, enough talking. Let's try to run this file. Let me open my terminal and we have to run this file, go run name.go and press enter. So there we go. Our key pair is generated and there is our pre-computed address. The credentials are saved to environment variables, as you can see. And now we have to fund this address, which is present here with these many Stark tokens. We can send a little more than that as well. So it is 0.01. I'll be sending some amount to this address. 0.03 and let's confirm this transaction. Okay, so our account has been funded and let's press enter to deploy. The transaction is submitted. Now we have to wait for confirmation. And there it is. The account has been deployed successfully. And let's verify this account on Voyager. If I open Voyager Sepolia, let me paste this. And as you can see, the account has been deployed. So that's it. We went from a 0 to a deployed starknet account and the entire code came straight from the docs. So bookmark this documentation and if you have any questions, there's a Telegram group which is linked in the sidebar. And thanks for watching. Go build something cool on starknet.